Hey all, I'm Sam again, and I'm again in a group with Austin and Tyler Terrio. So I'm going to be the reporter for our experiment 4, or possibly 3, I think I got it wrong, and it's the vapor compression refrigeration cycle that we did last week. Just a kind of quick reminder, this is what our apparatus looked like. I'm not going to go super in depth on like the apparatus and the experiment that we did, just because we already had a group lead report on this earlier, and it's kind of repetitive to do it again. So just going ahead and getting started, there were 2 exercises for this experiment that we did. Experiment 1 was looking at the power consumed, the heat generated, and the coefficient of performance. So these were the reported pressures that came from the software that we used. And then this is our predicted versus my experimental findings. I was the group lead on this a few weeks ago, so these were all my numbers that I found. So as you can see, our predicted power was way more than our experimental power. That came from the software itself. This is a lot better, which is great. And then produced heat used the equation that will be on the next slide. And the coefficient of performance, again, was a lot better than the one that was predicted. It is 1.16, which is great. That means it was more efficient than we had originally intended, which is good. So same with the electrical power and coefficient of performance. It did end up being better than what we originally intended. So these are the calculations that I used. Again, it's the predicted versus the experimental, just to see how the differences worked out. I think the biggest difference between why the numbers were different was because I was just using arbitrary temperatures, so there was really nothing going off of what I was doing versus the actual temperatures that we used to find the coefficient of performance, which kind of leads into a better coefficient of performance and a better produced heat. So for exercise 2, we found all of these pressures and temperatures based on the different outlets and inlets for the compressor and the condenser and the expansion valve. So we did 3 cases, which was 6 liters per minute, then 4.5, and then 3. So the next slides are just going through all of them. And then I based specifically my pH diagram on the very first case, which is 6 liters per minute. So we did all 4 state points. So we did state point 1, which was looking at the graph that was given in our lab manual, and we found the specific volume. And looking at that, we then found the enthalpy. So we did that for point 2, and then state point 2s was just kind of the same because we're going off it being ideal, even though it kind of wasn't. And then state point 3 and state point 4, and then on this is my pH diagram. It's a little hard to tell, but I did try to put it on the graph in our lab manual, so it's a little easier to visualize where it is, so you can see that it's way more accurate than the one from our previous lead presentation, just because, again, it was based on the actual experimental results. And then this is just a better version of it